Okay, so they're giving us this logarithm. Now it's a natural log, but it doesn't matter. It's the same thing. ln, or if they write log, whatever, the rules are the same. You know ln is just log base e. So all the rules are the same, no difference. Okay, so what do they want us to do? They want us to write it as a sum or difference in adding and subtracting of logarithms, plural, with no power. So they want us to write ln of something plus ln of something minus ln of something, right? That's what they want us to do. Several logs added, subtracted. Simplify your answer completely. No powers when we're done. Okay, let's review the rules. Here are the log properties, and these go for ln just the same as log. ln is just a type of log with a base of e. Okay, what are the rules? Multiplying for one log becomes adding for two, becomes easier, right? Adding and subtracting are easier operation. You learned them when you were kindergarten, first grade. Multiplying, dividing are harder. You learned them when you're a little older. So a harder job for one person, one log, becomes easier for two people. That makes sense, right? Multiplying becomes adding. For one log, dividing a hard operation becomes subtraction, easier for two. And then powers can come down to the front for one log. All right, with that in mind, let's do it. So I'm going to say, okay, now notice this. Here, let me write it a little bigger down here for us. This is ln, that's a little too big. ln of, I'm going to try to use the tool here. ln of, I want to make that a little bigger. There we go. ln of the fifth root of y to the 19th, w to the 8th, over z to the 7th. Okay, notice that that fifth root is over everything, isn't it? That fifth root is over everything. So here is the principle I've really got to make crystal clear for you. That if you have, here's the rule. If you have a fractional power like x to the a over b power, that's the bth root, which is fun to say, the bth root of x to the a. That b in the denominator swings around to be in the hook. So a fraction power equals a root, doesn't it? The denominator of the fraction power swings around into the hook of the root. Right there. That's what we see. Okay, so what? So look here. Anything in the hook, let me do it one more time, really clear for you. Anything in the hook can go where? Denominator. Of what? Underneath the power, like that. So in the hook, under. Why all three? Because the hook is over all of them. He's not over just the y or just the w or just the z. He's over them all. So this will become, oops, do a good check here. Y to the 19 over 5, the w to the 8 over 5, z to the 7 over 5. See that principle right there? Anything in the hook, right? Look over here. Anything in the hook is really a denominator power. It's two ways to say the same thing, like saying one and uno. Saying the same number in two different languages. Fractional powers and roots are two languages that you can say the same thing in. I don't know if you ever knew that. It's important if you're going forward in calculus and pre-calc to know that. Fractional powers or roots. Denominator of a fractional power goes in the hook or vice versa. So if it's in the hook, it goes back to the denominator of everything it's over. If it was only on the y, then I would only put it under the y's power, but it's over everybody. All right, so now what? Now I can break this into several logs. ln, this is times, so it'll become adding. And this is divide, so it'll become subtraction. right? Do we all see that? Do we see how multiply goes to adding, an easier operation for 2 logs? It's harder. This is just 1 log up here. So things are harder for 1 person, easier for 2. And then the dividing right here, dividing becomes subtraction, easier operation. It makes sense that dividing goes with subtraction because they both make numbers smaller, and multiplying goes with adding. They make things bigger. All right, last step, powers. Drop down to the front, powers down to the front, powers down to the front. That's property number 3 right here. Powers come down to the front. See that? That's in the front there. All right, powers to the front, powers to the front, powers to the front. So 19/5 natural log y plus 8/5 natural log w minus 7/5 natural log z. And there it is. Oops, kind of blew that a little bit, didn't I? There we go. There it is. There's the answer to that one. What did we do? What they said? We absolutely did what they said. Sum or difference, adding, subtracting, several logs, no more powers. Simplified it as much as possible. We did. There we go.